Hello and welcome to another episode of Astronomy Answered Simply. Today we're going to dive right in to a kind of a fun thought experiment about how to make another planet more livable. Specifically, I was asked about Mars. So the question is, would the impact of Ceres on Mars liquefy the planet? If so, how long would it take for the surface to solidify? And what if we add Pallas, Vesta, and other asteroids? So let's dig deeper into this question. First, would Ceres' impact on Mars liquefy the planet? Depends on how fast Ceres was moving when it impacted Mars. Ceres is about 1/10 the size and mass, maybe 1/12 the size and mass of Mars. So it's pretty small in comparison. So it would only really, unless it were moving extremely fast on impact, it would only liquefy an area around the impact. And the speed and power of the impact will determine how much got liquefied, because force equals mass times acceleration, Newton's laws of motion. So if there were more force, if it were coming in at a faster rate, that would mean more impact energy and more energy expended upon, to transform the surface to liquid. What if you add other asteroids? Well, it would not be enough to liquefy the whole planet. So the whole planet would still gain the mass of Ceres, most of the mass. Some of the ejecta would get shot right back out in space from that, and there would probably be a few more moons of Mars because of the resultant matter stream being spewed back out into space, and possibly even a volcano forming if there's enough liquefied elements. If you were to add additional asteroids to this, it would be very interesting. I mean, you would be heating up, thickening the atmosphere, and adding more mass to Mars. Now, you're not creating a magnetosphere, which is what Mars would need to be more long-term viable, to make it into a more Earth-like planet. But that's technology we just do not have. Now, if you were to take a Mercury-sized planet and maybe combine it with Mars, it would take millions of years for it to cool enough to even be remotely think about making it happen again. And I mean millions of years. Granted, Mars and Mercury combined would be a much better, it would make it a much more viable planetoid. But then we'd still have to wait for it to cool, wait a few million years for it to cool off enough to have a crust. It would then be geologically unstable, because it would still be liquefied. For the most part, the entire surface would be liquefied, and it would take thousands of years just to settle out into a stable mass. We don't have anything near the technology to shape that type of stuff. I mean, the energies involved are far beyond anything we're capable of right now. Even moving Ceres to impact Mars is far beyond our capability, let alone some of these other asteroids mentioned. Even though they're smaller, they're still beyond our capability to maneuver into an impact of Mars. Things that would be beneficial to Mars, if we were trying to terraform it, would be comets, specifically watery comets. Anything that's very, very large, water, carbon dioxide, ice, methane, things like that would be fantastic because they would thicken the atmosphere. In terms of mass on a planet, if you're talking a few mile wide asteroid to a something the size of a planet, it's really insignificant in terms of mass. But if you're trying to, if you're thinking long term, like thousands and hundreds of thousands of years, yes, it would be, beneficial if we're trying to actually terraform the planet. It would be beneficial to add, pummel Mars with asteroids early on before we got there and thicken the atmosphere, add some mass to it, make it more, slightly more gravitationally dense. You would need Ceres, you would probably need a few more Sedna, you would probably need a few more small planetoids to really try and increase the mass on it. Everything we send from Earth will be so insignificant. I mean, even a single like mile wide asteroid would probably send more mass than we are capable of sending from Earth in 50 or 100 years. So in terms of trying to create more gravity, it's just not going to happen, really, not with our current technology. But it's like I said, it's a kind of a fun thought experiment about how would you terraform a planet, and that's how planets were formed in the early solar system, was collisions between multiple objects, between smaller planets and asteroids, and just gas clouds and dust clouds coalescing and forming bigger and bigger planets. I mean, if you look at the moon, the surface is covered with craters. You can pick up a telescope, go outside and look tonight at the moon and see that there's craters all over the surface from various size asteroid impacts. That's basically, if Ceres were to impact Mars, there would be a huge impact crater visible probably from Earth. On a clear day, if our night was clear and the Martian atmosphere was clear and you had a big enough scope, you could probably resolve that crater from an impact like that. So it would be definitely redefine the surface of Mars, and would release a lot of energy. Would make it quite an interesting place at that point. So from a long-term survival perspective, it's neat, but we have no way to do that right now. Maybe in 1,000 years we'll have the technology to do that, but we don't even have close to the technology to do that. This is still the realm of science fiction, not engineering reality that we have now. So thanks for the cool thought experiment, and keep asking questions. Have a great day.